Hello guys, sorry for the inconvenience of late uploading the videos. I hope all of you are well in this serious condition. I request you all to not to go out from the home and stay inside. And second of all, regarding this topic of location of routes, I heard many people telling that this is very hard topic, but it is not true. This is one of the easiest topic you will ever get. Just you have to learn the basics and the graphical concept. So watch it properly till the end. So first of all, you have to understand the graphical properties of quadratic equation. So in this case, we will take two cases. First case, that is case 1. Here I will assume a. First of all, we take the quadratic equation y equals to ax square plus bx plus c, and the discriminant of this equation is b square minus 4ac. So in case 1, I will take a greater than 0. You must know that the graphical properties of quadratic depends on this a. That is a. So if a greater than 0, the quadratic will be towards upward direction, that is this type. If a less than 0, it will be in downward direction. So depending on a, there are 3 cases on d. First of all, first case, I take t greater than 0. In this case, if discriminant is greater than 0, we will have two different roots. That is, I suppose it is r1 and r2. These are two roots. In this case, d is greater than 0 and a is greater than 0, always, as it is directed towards upward direction. In the second case, I take d equals to 0. That is equal roots, two equal roots. In this case, I will get this type of curves, and it is root. It is x-axis, y-axis. I suppose this is the root is r, and in third case, I will take d less than 0. Here you will get no real roots. Here this is imaginary roots. See that it does not cut the x-axis, so there is no real roots. In the case 2, we will assume a less than 0. So here all the curves will be in downward direction. So first of all, I take d greater than 0. So the curve will be like, it is x-axis, it is y-axis. So the curve will be like this type. Two roots r1 and r2. Here a less than 0. In the second condition, t equals to 0. We will have the curve like this. It will just touch the x-axis. Here we will get two equal roots. I suppose the root is r. And in the third condition, where d less than 0, we will have the curve like this. It will not curve the x-axis again, so we will not get any real roots, and the curve will be like this. So first of all, you should know these six different types of things, and you can master the topic of location of roots. Hello guys, coming to the location of root part. So in this topic, first I will take five types of cases in which you will understand the whole topic of location of roots. I will only mention the types and explain to you, but the examples on different example on this, you have to do it yourself, and I will give the PDF of my material from Coaching Institute in the description of this video. So please check it out and let me know whether you had solved the question or not. So in general, if I take the function of x equals to ax square plus bx plus c, where a is the leading coefficient and c is the constant term, we will need this term, that is a f of k b and minus b by 2a, and k is any arbitrary number here. So I take type 1. In this type, if both roots of quadratic equation are greater than a given number k. In this case, both the roots of the quadratic equations is greater than a given number k. So here k is any arbitrary number. So in this case, if I assume a to be greater than 0, then the curve will be like this. If I assume a to be less than 0, the curve will be like this. First of all, I take a to be greater than 0, and k, here is k, as I have told that both the roots, that is r1 and r2, are greater than a given number k. So here is k, and this is two roots, and in this topic, in this part also, here is k, and these roots are r1 and r2. So you have to check it. So first condition is to get this type of curves, if to get this type of condition, that if both roots of the quadratic equation is greater than a given number, we will have to check three conditions. The first is a and f of x multiplied by f of x is greater than 0. If a multiplied by f of x greater than 0, and d greater than equals to 0, and minus b by 2a greater than k. Here minus b by 2a is the, here you should know that this, the maximum point, the coordinate of this is minus b by 2a and minus d by 4a. So it is x equals to minus b by 2a line, and it is minus b by 2a. In this case, you can check that minus b by 2a, that is x coordinate, should be greater than k, and d always should be greater than 0 in both the cases, and a multiplied by f of x is greater than 0. As if a less than, first of all, a greater than 0, so an f of k, that will be positive, so multiplied by f of k will be greater than 0. In this case, a is less than 0, and a multiplied by f of k, both are negative, so it will be greater than 0. So you have to check these three conditions and take the common part. In the second condition, that is type 2, the second type, that is if k lie between roots of quadratic. If k lie between the roots of the quadratic, in this type of questions, if I assume a greater than 0, this type, and a less than 0 here, so the roots here are r1 and r2, here also r1, r2. Here I have told that k lie between the roots, so k will be between this part, and I assume k is here, and here also k is here. So you have to check the condition that f of k, here a greater than 0, a less than 0. Here you can check that in both the cases, a into f of k always positive. In this, a is positive and always negative. Here you can check a is greater than 0, and f of k, that is value of the quadratic at the point x equals to k, that is this part, it is negative, so a into f of k is negative, and this part also a is negative and f of k is positive, so a into f of k, that is negative. So you have to satisfy this condition and take out the common part. In the third type, that is type 3, it is if one of the root of quadratic equation is less than k1 and other is greater than K2, where K1 is less than K2. This is the condition. And if I take two cases, that is, I assume first case a to be greater than 0, and the second case a to be less than 0. If the roots are r1 and r2, and the two arbitrary points, that is k1 and k2, I take k1 and k2. See, k1 is less than k2, and here also r1, r2, k1, k2. So here you have to satisfy that here a greater than 0. So you can check that a into f of k1 is less than 0. Similarly, a into f of k2 less than 0. In both the cases, here a is negative and k1, f of k1, f of k2 positive. Here a is positive and f of k1, f of k2 negative. So these two conditions will satisfy, and you have to check these two conditions. And coming to the next part, that is type 4. That is type 4. Here the condition is if both roots of quadratic equation lie between k1 and k2. Here also k1 less than k2. I will get two cases for a greater than 0, this type, for a less than 0, this type. For a greater than 0, I take this is k1 and this is k2. See, if both the roots, that is r1 and r2, lie between k1 and k2, and in this part also I take k1 here and k2 here. So the conditions you need, that is a into f of k1 should be greater than 0. See, a is greater than 0 and f of k1 also greater than 0. Here a is negative and f of k1 is negative. So multiplication of a into f of k1 is positive. Similarly, a into f of k2 is also greater than 0, and d should be greater than equals to 0. And I have told you that this point is minus b by 2a or minus d by 4a already. Here also minus b by 2a, minus d by 4a, coordinate of this point. So k1 less than minus b by 2a less than k2. This is the next condition. You have to check these four conditions and apply it properly, and you will get the solution. It is very easy. You have just have to understand the curve. And coming to the type 5, if exactly one root of quadratic equation lie between k1 and k2. This is the type 5 question. So for a greater than 0, there will be a curve. A less than 0, there will be a curve. For a greater than 0, I assume the curve is like this. For a less than 0, curve is like this. If exactly one root is between k1 and k2, so I assume this is the root which lie between k1 and k2, that is k2, k1. Here also, if I assume it is the root and it is k2 and it is k1, so you can check that f of k1, that is the value of the function at the point x equals to k1, and f of k2, these both are in opposite direction in both the cases. So f of k1 multiplied by f of k2 is less than 0. This is the only condition here. You have to check and get the correct results. So guys, I will give the PDF of my coaching material to the description of the video, so check it out, and if any problem there, please let me know in the comment section and I will try to solve it properly. So thank you for watching the video.